Okay, today let's talk a bit about springs. Let's put an object on the screen for us to play with. And let's go to its properties and turn off its central pivot and turn off its responding to gravity property. And now, of course, if I go into kinematics and hit play, it simply falls off of the screen. But if you have one object selected and press spring, you can attach an object to our plywood background. We hit stop and there is our spring. So you can move your connection points of your spring as you wish. Just by dragging them around. And if we hit stop and play, and you'll notice I always hit stop before play just to reset the system. You can see our object hangs down on its pivot. You can drag it around and it reacts like a spring. But the spring does not have a lot. You see how slowly that's settled. And if I pull it down and let go, there's not a lot of energy in the spring. And the energy in the spring is a function of its damping. So if we hit stop and select the object again and hit spring, we'll come up with a dialog allowing us to set some items in spring. Stiffness is the amount of force the spring has, so that would affect how far down that object is going to hang. Damping is how much energy is in the spring. It's the energy loss per second in the spring. Let's move that down to 0.05 so that we lose very little energy from the spring as a natural function of the spring. The energy will still be lost through normal entropy of the system, damping of the world, and so on, but in this case, we won't damp it out of the spring purposely. Now you can see the object bounces some, and if we pick it up and move it, it's got a dynamic energy to it that doesn't get damped off very quickly. So that's the function of damping. Let's take a look at the function of the stiffness. The stiffness here is 1. If I move stiffness up to, say, 3, it'll now be 3 times harder for that object to pull on that spring. We hit stop and go, and you can see it doesn't fall as far. The springiness is still there. That's a function of the damping, and we didn't change that, so it will tend to follow itself. Now let's add another object. Let's add a ball here, and let's also take away its central pivot. We'll leave it its gravity and allow it to rotate. Now, if we select 2 objects, we can add a spring between them. And we hit stop in order to be able to see the spring. And there's our spring between those 2 objects. If we now hit play, you can see that the first spring now stretches further than it had before. It's now bearing the mass of both of those objects. So if you connect more things by spring, you are, of course, going to have to adjust their stiffness and their damping. There is no correlation between the settings that you're given these springs and some spec for a spring that you might want to buy. It's simply a relative number, and it's something that you can consider as a relative strength between springs, but I don't think it's valid for anything more than that. For this next example of how a spring works, I've put a little box on the screen, and I'm going to set it as a static object, which means it doesn't move. And I'm also going to change its friction from 0.4 to 0 so that it's not affecting anything on it that's sliding. Things will be able to slide based on their own friction, not the friction of this surface. I'm then going to put 2 boxes on the screen. 1 and 2. And I'm going to select both boxes and turn off their central pivots down here and turn off their gravity and update all between them and hit OK. And now these 2 objects should just fall and stay where they are. And that's what one would expect. But now I'm going to put a spring between them. And we'll put the spring right in the middle of the objects and tell it to run. And you'll notice that because the spring is set at its natural length, it doesn't push the objects apart, nor does it pull them together. This is a function of the preload of the spring. So if I stop this and bring up the properties of this spring, you can see preload is set at 100. That means the original length of the spring is the length of the spring when it's at rest. If we were to say 150%, and then stop and play, you can see that the 2 objects get pushed further apart until the spring reaches its natural length, which we've told it was 150% of the original placement length. Alternately, if we were to shorten that and say that 25% is the normal length of the spring compared to where we placed it, the spring will now want to pull itself together until it reaches 25% of its original value. All right, I think that's all we need to say about springs. Have fun playing with them, and let me know how it works out.